Hello everyone, welcome to Algebra 2B, week 5. We're going to be getting into solving rational equations. So make sure you're going through a textbook, using this class recording, taking notes, doing all that stuff that good students do as you're working on all your assignments for your class this week. For what we're doing on this week 5, here's the objectives that we got. We're going to be looking at adding rational expressions that have different denominators by multiplying to get common denominators. Finally, we're going to look at complex fractions. That's a fraction divided by a fraction. We're going to learn how to simplify them out a little bit nicer. Then we're going to get into solving equations. If I give you an equation with rational terms, can we recognize and use cross multiplication as a method, or by using the least common denominator? So again, some more stuff of just working on adding, subtracting, multiplying, dividing with rational expressions, and then solving rational expressions. Let's get started. So last week, in week 4, we started working on learning how to add rational expressions. We did a little bit right at the end, but we only focused on expressions that had like denominators. And we saw that you can just add or subtract the numerators when you get to that case. In this lesson, we're going to pick up on that and learn how to add or subtract if you have different denominators. So let's take a quick review. Back in middle school, when we learned about fractions, what did we need to do? How would we add the following fractions together? Well, right now, as is, I can't. 3/4 means I have 3 out of a whole divided into 4 pieces, but 2/5 means I have something divided into 5 pieces. Those are different size pieces. So what we would do is we would find a common denominator. Let's say both are out of 20, because 20 is a multiple of both 4 and 5. Since 4 times 5 is 20, I multiply 3 times 5 to get 15 out of 20. That's the same as 3 out of 4. We find a similar fraction. 2 out of 5, I multiply the 2 by 4 to get 8. 2 out of 5 is the same as 8 out of 20. So now I've got two fractions with the same denominators, the same size of fraction. So 15 out of 20ths plus 8 20ths is going to give me 23 20ths. And then we could reduce that down into 1 and 3 20ths, back into a mixed number. But that's how we would do it. We would multiply to make the fractions have the same denominator. That's what we're going to do, the same thing when we're dealing with rational expressions. So when working with rational expressions, you first want to factor the numerator denominator, simplify it down, because then it's easier to know what to multiply by. We multiply one or both of the fractions to get common denominators, multiply both the numerator and denominator. And then we can add or subtract the numerators and then simplify the final resulting fraction. Let's do one of these together. Here we go. We got 5 out of 5x squared minus 64ths. And I'm subtracting from that 6 over x times x plus 8. And we're going to add those two rational expressions together. Well, the first thing I want to do is rewrite it in factored form. So 5 is good, as is, can't factor that down. But x squared minus 64 is a difference of two squares. I can rewrite that as x minus 8 times x plus 8. And I'm going to subtract from that 6 over x times x plus 8. All right, now let's compare what we've got. And we want to look for what I need to do to get common denominators. Well, one nice thing I can see right off is both of them have a factor of x plus 8 already. So when I'm trying to find common denominators, they already have x plus 8, this whole binomial factor, in common. The only thing that's different is that this one has a factor of x minus 8, and this one has a factor of x. That's kind of what differentiates them. So if I want to make the same, I need to multiply this fraction here by x minus 8 on the bottom and the top, numerator, denominator. And I need this factor of x to appear over here. So I'm going to multiply by x in the numerator and denominator on the other fraction. Look at what we got now. Let's switch colors. So now we've got, ooh, look at that cyan. Ah, hurts my eyes. But we have x times x minus 8 times x plus 8. And we have another x times x plus 8, x minus 8. We have common denominators at this point. So let's rewrite it. And I'm going to rewrite what I have now under one common denominator. So I have x times x minus 8 times x plus 8. But in the numerator, now I've got 5x minus whatever 6 times x minus 8 is. Got common denominators, now I'm able to subtract the numerators. I got some stuff I can simplify in the numerator, so let's do that. So let's distribute the 6x. So that becomes 5x minus 6x plus 48. The plus 48 is because we have a negative and a negative. And then I can rewrite that as 5x minus 6x is just negative x plus 48. And on the bottom, our common denominator is still the same. So x times x minus 8 times x plus 8. Now you always want to do a quick check at this point. We add them together, we simplify the numerator. Are there any common factors that you can divide in the numerator and denominator? Well, I have factors of x, x minus 8, and x plus 8 in the denominator. But I don't have any of those factors in the numerator. I just have negative x plus 48, which is different than any of those three. So that's my final answer. I can't simplify it anymore. But there we go. We just successfully added these two rational expressions together. Well, in this case, subtraction. All right, so you're now experts at multiplying. You're experts at division, which we can change into the reciprocal, and we already did this last week. But now let's look at complex fractions. Complex fractions are one in which you have a numerator and denominator are both fractions. Generally, we don't really like complex fractions, but we always kind of learn about them and work with them in any sort of unit on rational expressions in Algebra 2. To simplify a complex fraction, we just need to do whatever we need to get it into just one fraction with a polynomial in the numerator and a polynomial in the denominator. So let's kind of take a look at an example here. Look at this big mess. So we've got 8 minus 3x over x plus 5 divided by 10 divided by x plus 5 plus 5 over x plus 1. And we want to simplify it. Remember, my goal is to get a polynomial in the numerator, so no fractions up here, and a polynomial in the denominator, no fractions down there. All right, so how are we going to go about doing that? Well, one way to do it is just to focus on each in a turn. So I have a division by x plus 5 over here, right? So I can take and multiply x plus 5 on the top here. And I can multiply this by x plus 5 on the top there and rewrite the whole thing. What does that give me? Well, now I've got 8 times x plus 5 minus these x plus 5s cancel out. So now we've just got minus 3x. The problem is if I multiply the numerator by x plus 5, I got to keep the fraction the same. So I got to multiply the denominator by x plus 5 as well. So let's do that. What happens when I do that? Well, it works okay for this term right here because I have an x plus 5 multiplied by x5. Those divide out, so that just leaves 10. But it gets a little bit sticky here because I have an x plus 1. That doesn't divide out. So I've still got plus 5 times x plus 5 over x plus 1. So we simplify the numerator by multiplying everything on the top and bottom by x plus 5. But I still have another fraction there. Guess what I need to do to get rid of this division by x plus 1? I'm going to multiply everything out by x plus 1. So let's multiply this times x plus 1. Let's multiply this times x plus 1. If I multiply the denominator, I got to also multiply the numerator. So let's multiply every term there by x plus 1. Hopefully this is making sense, but what do we have now? We have 8 times x plus 5 times x plus 1. We multiplied both of those factors minus 3x times x plus 1, all divided by 10 times x plus 1 plus, and here's where it gets a little bit nicer, x plus 1, x plus 1. Those divide out to leave just 5 times x plus 5. There we go. Now we do not have any fractions in the numerator and we don't have any fractions in the denominator because we multiplied both the numerator and denominator by binomials such that they divided things out. We had to multiply everything by x plus 5 because I had those as fractions, and we had to multiply the numerator and denominator by x plus 1 to get rid of that fraction as well. But I still got some work to do. I still got to simplify some stuff out. So let's do some distributing. Let's do some multiplication. I'm going to multiply things out right here. So we got x squared. X plus 1 is 1x plus 5x. That's going to be plus 6x. And then 5 times 1 is plus 5. That's still all multiplied by 8. Minus, I'm going to distribute that as well, minus 3x squared plus 3x. On the bottom, we've got 10x plus 10. Once I distribute those, plus 5x plus 25. And I need to do one more little bit. I need to distribute this 8 up here to get 8x squared plus 48x plus 40. Now we can do some adding, subtracting, combining like terms in both the numerator and denominator. So let me switch back to red. So in the numerator, I've got 8x squared, but I've got a minus 3x squared. So the net effect is to have a 5x squared. Now we've got 48x. And by the way, this should be, because I had a negative 3x, I distributed, I should be a negative right here. I made that mistake. So make sure you don't make mistakes on distributing your negative. That negative needs to both go with the x and the 1. So we got 40, but we got that there, 8x squared minus 3x squared. Now I've got 48x, but I need to subtract that 3x, so that's going to be plus 45x. And I've got a plus 40 on the end right there, so plus 40. So that's what the numerator is simplified out into. On the denominator, it's a little bit nicer. It's 10x plus 5x, so it gives me 15x. And then I've got 10 plus 25, so that's 35. Okay, look at that. We're making some progress. One thing that jumps out at me, 5, 45, 40, 15, 35. I got some common factors of 5s around here, right? If I factor a 5 out of the numerator and factor a 5 out of the denominator and divide out that 5s, I'm left with x squared plus 9x plus 8 divided by 3x plus 7. And I can see that the top actually factors into x plus 1 times x plus 8. But I don't know if that really helps me because I don't have any common factors like that in the denominator, just 3x plus 7. But there we go. The whole point is we got rid of our fractions in the numerator and denominator by multiplying the numerator and denominator by whatever binomials we needed to cancel out those fractions. So we had a fractions of x plus 5. So that's what we multiplied first in the numerator and denominator. And then we had a fraction of x plus 1. So we multiplied those over here with all the terms. Then once we had a polynomial in the numerator and denominator, we had to do some distributing, some multiplying, and then some combining like terms and simplifying. But we end up with a final answer that is a polynomial in the numerator and denominator and is simplified out. That's how we work with complex fractions. Whew, all right. Let's switch gears. We now know how to add, subtract, multiply, divide. We now know how to deal with all sorts of rational expressions. But now we're going to switch gears. Instead of expressions, now we're going to work with equations. Solving equations that have rational expressions in them. The easiest one is just when you have one rational expression set equal to another. It looks kind of like cross multiplication, which you've done before, you've seen before. This may be a little more complicated, but the idea behind cross multiplication is if you have one rational expression equal to another, you can multiply it and change it into this form, something times something else. So here's an example of that. Let's solve this out. You got an equation. I want to figure out what value of x makes both sides equal to each other. First thing I always recommend is factor, factor, factor. So I'm going to change this to x minus 4 on the top left there. X squared minus 1 is the difference of two squares, so that's x minus 1, x plus 1 is equal to 2 times, and then what does this factor into? It factors into plus 5 minus 1, x plus 5 times x minus 1. Okay, now we can recognize we have one rational expression set equal to another, so we can change it into a different form by using cross multiplication. And rewrite this as x minus 4 times x plus 5 times x minus 1 equals 2 times x minus 1 times x plus 1. You're like, well, that doesn't make it any easier. That makes it look harder. But it's not that bad because some things are going to work out nicely. Watch what happens when I notice, oh, we've got an x minus 1 factor here, and I've got an x minus 1 factor here. When solving equations, I can do the same thing to both sides. Let's divide the left side by x minus 1. Let's divide the right side by x minus 1. Those two divide out to make 1. Those two divide out to make 1. We're left with x minus 4 times x plus 5 equals 2 times x plus 1. All right, we still got some work now, but let's go ahead and distribute, multiply. Let's try and turn this into a polynomial set equal to 0. So if I multiply all this out, I'm going to get x squared plus 5x, but then I have a minus 4x, so that's x squared plus x minus 20 equals 2x plus 2 once I distribute that. And now I'm going to subtract 2x from both sides. I'm going to subtract 2 from both sides, and I'm going to get over here, we've got x squared minus x, and then minus 2 from both sides, minus 22 equals 0. And again, I got the minus 2x, I got the minus x because I subtracted 2x from both sides, and then we subtracted 2 from both sides. Okay, so there is my new polynomial. And going back to this, I want to solve this out. I want to try and find what are my solutions for x that make this work. Well, I'm going to briefly look at trying to factor. Are there two numbers that multiply to negative 22 but add to negative 1? I can't think of any right off, so it doesn't factor nicely, which means I got to use the quadratic formula in this case. So x is going to equal negative b. B is 1, so it's positive 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a, which a is 1, times c, which is negative 22, all divided by 2 times a, 2 times 1. Simplify what's under the square root. X equals 1 plus or minus 1 plus 88, so that's going to be 89. 4 times 22 is 88. And the negative make it plus, so that's square root of 89 over 2. And the square root of 89, it does not simplify. It does not simplify at all, so that's my final answer. My two solutions is if I make x 1 plus the square root of 89 over 2, or 1 minus the square root of 89 over 2, that is the solution, two solutions to this rational equation. And you want to double check really quickly that whatever your solutions are, that if I put them in, I don't get division by 0. And if I put that in, the only way to get division by 0 would be if x is 1, or if x is, let's see, that factors into if x is 1 or if x is negative 5, and I don't have either of those there. All right, so that's cross multiplication and using it to solve rational equations. What if we have multiple terms? What if I have something like this? Again, I want to be able to solve them out. This is not an addition or subtraction problem. This is a solving out. I want to turn it into a problem without fractions, because then it's much easier to work with. So how do we get rid of fractions? We multiply everything by stuff that divides out the fractions. So let's look at what we need to multiply out. I need to multiply by a 4 times x to cancel all those out. We have a factor of x plus 2 that we want to have divided out. And then we have x squared plus 2. Well, that factors into x times x plus 2. But I already have an x plus 2 and I already have an x. So this right here will divide out the 4x, the x plus 2, and the x times x plus 2. It'll divide out all those. This is what we would call our least common multiple, right? It's the expression that each of those is a factor of. So that's what we're going to do. We're going to multiply this first term, the second term, and this third term right here. We're going to multiply everything by 4x times x plus 2, and then we're not going to have any more fractions. So it's going to look a little messy as I write it, but let's just do it all so you can see how it works. So I'm going to put the original equation in blue. So we got 5x minus 3 divided by 4x. And then we have minus, let's subtract from that, x plus 1 over x plus 2. And that's equal to 1 over x. I'm going to leave it in factored form, so x times x plus 2. And what we're going to do is multiply both sides of the equation by our least common multiple. So I'm going to multiply 4 times x plus 2 here. Multiply 4 times x plus 2 here. And we multiply 4 times x plus 2 here. Every term on both sides got multiplied by the 4 times x plus 2. Here's why it works out really nicely. The 4x divides out with this 4x, leaving just x plus 2 times 5x minus 3. This x plus 2 divides out with that x plus 2, leaving 4x times x plus 1. And this x and x plus 2 divide out with that x and that x plus 2, leaving just 4. I like that one the best. There's my new equation with no fractions. Still got some work to do, but it's going to be a lot easier to deal with without having to deal with all these fractions. All right, so what do we got to do now? Multiply, simplify, combine like terms. Let's rewrite this by multiplying everything out. So we got x times 5x. I'm going to rewrite it here. So we've got 5x squared. Then we've got minus 3x. And then we've got plus 10x. And then we've got minus 6. And now we've got minus all this. So I've got to distribute that negative 4x. So we've got minus 4x squared. And we've got minus 4, and that equals 1. Whoops, equals 4, not 1. There we go. There's some like terms that I can combine. So 5x squared minus 4x squared is going to give me x squared. That's nice. Negative 3x plus 10x is going to give me 7x. And negative 6 minus 4 is going to give me minus 10. All right, feeling good about that. And it's still equal to 4. If I want to solve I got a quadratic now, a second degree quadratic. If I want to solve a quadratic, I need to set everything equal to 0. So let's subtract 4 from both sides. And now we've got x squared plus 7x minus 14 equals 0. First thing I want to do, if I'm going to solve this now, I'm going to find my values for x. I want to see if I can factor this really easily. Are there two numbers that multiply to negative 14 but add to positive 7? Well, to get 14, there's only 7 times 2, or 1 times 14, and there's no way to get that. So I got to use the quadratic formula again. Good thing we're so good at the quadratic formula, huh? So x equals negative b, so negative 7, plus or minus the square root of b squared, so that's 49. 7 squared is 49, minus 4 times a times c, 4 times 1 times negative 14, all divided by 2 times a, 2 times 1. Okay, so what is that simplifying there? 4 times 14 is going to be 56. So I've got 49 plus 56. Calculate that out. 105. So we've got negative 7 plus or minus the square root of 105, all divided by 2. The square root of 105, I don't believe I can simplify that down. It does not divide by 4, does not divide by 9, does not divide by any perfect square. So that's going to be my final answer. There's two solutions. X equals negative 7 plus or minus the square root of 105 over 2. These are heavy-duty problems, but this is how we go about solving rational equations. It's really similar to how we would solve and work with just fractions in an equation in general. If you're wanting to solve an equation with fractions, figure out what to multiply on both sides so that you can divide out all the fractions and you're just left with a polynomial equation to solve. In this case, we had to use a quadratic formula because we had a second degree polynomial, so it took some work. But hopefully it's nothing crazy new. It just takes some time and step by step. Okay, we are done with week 5. We did a little bit of adding. Again, how to get common denominators so we can add or subtract rational expressions. We simplified a complex fraction by again multiplying the numerator and the denominator by the same thing in order to get rid of fractions. We kind of did the same thing with solving rational equations. We multiplied both sides by whatever polynomial we needed such that it would all divide out nicely. Again, if you have questions, hopefully this video is a helpful resource, but if you have questions or if you get stuck on the paper pencil, give me a call, give me a text. Love to work with you to help you understand this stuff better.